Let's go now to the, okay, class. The second factor that affects the availability of the nutrients is the capacity factor. And the capacity factor refers to the ability of the soil to replenish the nutrients in the soil solution. So, if for example, one nutrient or one nutrient element has been taken in by the roots of the plants, then uh, these cations which are present in the exchangeable form or in the exchangeable site or the soil colloid will replenish what has been taken in from the soil solution. That is what it means by the capacity factor, or that is what you call the ion exchange. Because maybe you have discussed about the ion exchange, which is the a reversible process. Yeah. So that is how this capacity factor. So it's the ability of the soil to replenish the nutrients that has been taken in by the plants in the soil solution. So once, for example, calcium has been taken in by the plants or the roots of the plants, then the soil will replenish, could either be by your magnesium, which has two valence also. So that is what it means by the capacity factor. Now, what are the factors affecting the capacity factor? So, one is the kind of soil. So, different soils have different capacity to replenish what has been taken in by the roots of the plants. Uh, Nutrients, for example, for example, in tropical soils, red tropical soils, this is a red soil, okay? They have high absorption capacity. So what does this mean by the word adsorption capacity? That means that they absorb. That means that the nutrients or the elements, nutrient elements are adhere, or they are attached to the soil colloid, which cannot be released immediately. So yun ang ibig sabihin ng different kind of soil. Usually red soils are acidic. So when it is acidic, that means to say that it can also affect the availability of nutrients by the action of these uh, elements like iron, which are present in the uh, soil. So to maintain this, to release this in the soil solution, or to maintain the equilibrium between the soil solid and the soil solution. So, ibig sabihin niyan is, yung red soil, it will absorb. Absorption means the adherence or the clinging or the attachment of the nutrient to the soil. Kasi negatively charged yung soil, then this will be attracting the positively charged ions. So they cling to the soil, and then they will not be available to the roots of the plants. On the other hand, podzols also moderately leached have lower phosphate absorption and hence is more available to plant in the soil. So moderate meaning leaching of this phosphorus, available phosphorus is not rapid, or it is a little bit slow. So moderate yan. Not so slow but not so fast also, which means to say that the uh, absorption capacity there is good also. So which means that the phosphorus will be available to the roots of the plants. Yan ang kind of soil. Now, another is the kind of nutrient element. Okay? For example, the potassium, calcium, or magnesium go into rapid equilibrium with the soil solution. On the other hand, the potassium, which is fixed in the clay lattice, if it is shown in this figure, that the potassium here, so one layer of silicate and then another layer, so they are parang nasa-sandwich yung potassium in the clay lattice, so it will not be available. Kaya fixed potassium yun, especially in the 1:1 type of clay. Kaya that's another kind of soil. And then the nutrients that are that are fixed are this one. Nitrogen also, phosphorus, sulfur bound, but this nitrogen and phosphorus and then sulfur are also absorbed in the organic matter content. Yung organic matter diyan is negatively charged also, so they can be attached into the organic matter content of the soil, okay? And then they could be only released during the weathering and decomposition of this organic matter, okay? Another factor is the rate factor, that will determine the availability of the nutrient. So, capacity factor, one is the pH, oxidation reduction, no, capacity factor. Okay, intensity factor is one, and then the other is the capacity factor, and then this rate factor. Rate factor, it refers to the rate of nutrient element released into the soil solution. Siyempre, the more the nutrients, the more they will be released, okay? The rate varies with the solubility, however, or the release of nutrients from the mineral or organic sources in the specific soil. If you can see from this figure, these soil rocks and minerals, solid rocks and minerals, they will only be available. This potassium, like feldspar as a source of potassium, will only be available upon the decomposition of this solid rock, or they are unavailable, so they can be only available when they are being weathered slowly. Yan ang rate factor, okay? So the more the potassium are present in the soil, the more that will be taken in by the roots of the plants here. So they will be readily available in the soil water or the soil solution, and then or also in the soil colloid. When this mineral will, or rock mineral, say for example the feldspar, will be weathered. Yan. Now, the availability could be classified as 1, readily available, moderately available, and difficultly available. When we say readily available, these are the ions or the nutrients in the soil solution. So, for example, urea is very soluble in water. So they will be readily available in the soil solution when the roots of the plant will come in contact with this, then they will get it. Or so if they will absorb the water, then they are taking in also ammonium there. Moderately available when these nutrients these are readily decomposable organic matter or the exchange site. So these are these are present in the soil, but moderate dahil sa organic matter, for example, it has to undergo mineralization or decomposition before these nutrients could be available. Say, for example, yung mga dahon, leaves, branches, and twigs, so when they decompose, then they will not release immediately the nutrients, but still they become part of the soil organic matter. When the soil organic matter will undergo again decomposition, then they will release nutrients, and then of course, there will have your humus. Yan ang mga moderately available nutrients, or they are present in the exchange complex. They will be taken only when the roots will come in contact with these nutrients. Number 3, difficultly available, meaning these are what is present in the rocks. Let's look at this one. The solid rock, for example, Okay, yung solid rock, the potassium will only be available when they will undergo the decomposition or weathering process. Yung weathering kasi is the it involves the physical and the chemical weathering process. So, the disintegration and the decomposition of these rocks will release now the potassium, for example, the feldspar. So, yan ang mga difficultly available. So, it takes time for these nutrients to be taken in by the roots of the plant because it has to undergo the weathering process, which are usually the nutrients present in the rocks. All right. Now, how are the mechanisms of the ion uptake? How these nutrients are taken in by the roots of the plant? So, through this theory, which is the passive absorption and then the active absorption. So we'll discuss this when we are the diffusion, the mass flow, the ion exchange theory, but we will not discuss this doon on equilibrium. Ito lang, diffusion, mass flow, and exchange. Yung active naman, kasi how do we differentiate passive and active? Ayan. So, mechanisms of nutrient uptake. So how are these nutrients taken in by the plants? So one, uh, here, the surface of the leaves and stems as well as roots can absorb nutrients. But the carbon dioxide is absorbed by the leaves, which is the major avenue for obtaining the carbon as a source of nutrients for the plants. Now, these are the mechanisms by which this could be, the nutrients or the elements or ions are taken in by the plant. So mass flow, diffusion, and contact exchange. What are these? So yung mass flow, this is the process whereby the nutrients are carried by mass movement of water towards the root. As the water is absorbed by the roots of the plants as a result of transpiration. Now, see how is this process taking place in the soil. Okay. For example, we have in our discussion about the soil solid, which is the soil, and then we have the soil solution, which is the water. Now, the water moves from lower concentration to the higher concentration. So, siyempre, kung magtra-transpire yung tubig sa tanim at saka evaporation, now they are carrying with it nutrients. So, when they come in contact with the roots of the plants, then the plants will take this. Yan ang mass flow. That is through evaporation and percolation of water. Yan ang evaporation. Kung percolation naman, the downward movement of the water. So when the water is going down, that means to say that it is also carrying with it nutrients. So kung na-intercept yun ng roots of the plant, then it can take the nutrients. That is what we call mass flow. All right. The mass flow, of course, is dependent on the amount of water flow. So when there is less water, there is a slow movement of the nutrients to the roots. Okay, this is affected by adhesion force. Adhesion force, that means to say that the attachment of this water to the soil. And then the other one is the rate of water flow to the roots. Kung slow din yung movement ng soil solution to the roots, then it will affect also the movement of these nutrients. All right. The mass flow is the major avenue by which plants absorb this calcium, magnesium, zinc, copper, boron, and iron. Mobile ng mga nutrients ay nitrate, chlorine, at saka sulfuric din. So, mobile yan, easily taken in by the plants. But yung carried by the water are mostly this calcium, magnesium, zinc, copper, boron, and iron. Okay. So, the other way or by which these nutrients are taken in is through diffusion. Diffusion is the movement of ions from zone of high concentration to a zone of low concentration. Okay. It's just like this one. So, highly concentrated, halimbawa, this is the nutrients. So, when it goes there, it becomes lesser and then it is diffused. So, it becomes, there it is throughout. And then that is how now it will be taken in a region of high concentration to a region of low concentration. An example here is that, all right, if you stay in the door and then you fart, there is high concentration of carbon dioxide that is released. When air comes in, it diffuses throughout the room. So therefore, you can now smell the part of that person. It's just like these nutrients. So na ano yan, high concentration tapos mag-diffuse yan sa soil or sa yung uh, nutrients, then it will be taken in by the plants na yan. Kaya diffusion means this one. So, eto, highly concentrated, para bang kung syrup, tapos lagyan mo ng tubig, siyempre, yung tubig din, it will become more. So, ayan, parang ganun na lang ang dispersion. Nag-disperse na sila, so they can be taken in by the roots of the plants. Another mechanism is the contact exchange. The contact exchange actually is the interception of the roots of the plant with these nutrients. Take this for example, okay? So when this root of the plant directly comes in contact with these nutrients here, calcium, magnesium, aluminum, hydrogen, sodium, they can be taken in by the root hairs of the plant. That is contact exchange. Halimbawa, okay, all right, the root is here. Now, so, yung mga nutrients na dyan, na dito, pag nag-contact itong nutrient at saka root, siyempre, yun, they can intercept this, then they will get it. So, yan, halimbawa ito, sa halimbawa, ano na doon yung nutrient. So, ibig sabihin, this can be taken in by the root of the plants. So, after these nutrients are present in the soil or the clay particles. Siyempre, ng root, they will be here. So, the longer the root, the more nutrients will it take also. Kasi those are, the longer the roots, that is the factor that also affecting the contact exchange. Okay. So, meron din yung carrier theory. How are these nutrients carried and then carried to the from the root to the organ and organ of the plant so that it will develop or it increase in size. So, carrier theory. There is what, kanina, na-discuss natin is how yung passive at saka active. So, the first stage is the passive uptake, which means to say that yun, na-diffuse na. Yung mga nutrients, high concentration, tapos nag-diffuse yan, and then they will be taken in by the plants kung nandyan na sa lupa. And then the active is, the second step is active uptake. So, kung nandun na sa roots of the plant, so it requires energy for this ion to be carried. So, a carrier energized by the plant metabolism picks up the ion and carries it to the inner space of the roots. After depositing this ion, the carrier repeats the process. So, ganun na process. Yun ang carrier theory. Parang, nag-contact yung mga nutrients doon sa tanim, it will be taken in first, or passive yun passive. Tapos yung active, it requires energy, and these ions are carried by, carried to the inner space of the roots, and then it will be from organ to the organ. Yun, ang active uptake, second step. What are the factors affecting the uptake of the nutrients by plants? So the soil factor, na-discuss din ito. So, availability of oxygen supply, nutrient concentration, ito yung rate factor, yung nutrient concentration, and then the moisture and soil temperature. Okay? Kung poor yung aeration, it will affect also the movement of the nutrients. Okay? Kasi hindi makaano yung tubig. Hindi maka-move sa soil, so it will not be taken in by the roots of the plant. Yun ang soil factor. Yung natin, pati yung kind of soil na discuss na yan. Tapos yung plant factor. Of course, the root density or the contact exchange will be affected by the root density. Kung ang root density, hindi root length, ang root density, the more the roots, yung root density, the higher the roots present in the to the plant, then the higher would be the absorption of these nutrients. So the denser and more widely distributed the plant roots, the greater the nutrient also. Of course, if it is also dense, meaning it is ang daming roots, root hairs, and then it will, of course, get more nutrients. Mm. Root exudates can also stimulate the growth and development of the soil microbes, which can produce organic acids, and then, excuse me. So, uh, syempre, yung exudates na ito, nilalabas ito ng root. Okay? Kung nag-absorb ng okay, exudates can stimulate the growth of soil microbes which can produce organic acids. Itong mga microbes na nandun sa lupa, they are producing acids which could solubilize the phosphorus that can be taken, that will be released, and then it will be taken in by the roots of the plants. Microbes on the root surface also can affect the nutrient uptake. So, they can alter the morphology of the root and root hairs. Siyempre, kung yung microbe ay sinira yung tanim, sinira yung root of yung ugat ng tanim, then siyempre, kung may sugat, hindi maka-absorb yun. So, ibig sabihin, yun ang isang factor dyan. But, ano pa? The morphology of the roots and root hairs compete against roots for nutrients and water and physically block the root surface against iron absorption. Okay? So, yun ang microbes that are present on the root surface. For example, yung mga nematodes, siyempre, sisirain yung mga root of the plant, so it will not take in more nutrients through the water. Pati yung pag naklabrot yung tanim na cabbage or crucifers, they cannot absorb more of this water. So, less nutrients also are taken in by the plants. So, ganun ang effect ng mga microbes. Alright? Okay. Relationship between the soil nutrient supply and then the plant growth. There is what you call law of the minimum by Liebig. Okay? Ibig sabihin nito, only the most deficient nutrient limits the yield and the rest are considered in excess. Ibig sabihin nito, kung may element which is deficient in the soil, siyempre maapektuhan yung development ng tanim. So, it is that, as for example, nitrogen is limiting. So, hindi mag-develop ng chlorophyll na maganda yung leaves of the plant. So, the yield will be limited by the amount of that nutrients. In the smallest amount yan, yung kalimbawang nitrogen. So, crop yield is limited by the amount of nutrients which is present in the smallest amount. Halimbawa, kukulang yung deficient yung also potassium. So, tubers will not develop because one of the functions of the potassium is to carry the photosynthase. Energy also is required. So, that is in the form of ATP, so which is the phosphorus. So, pag yan ang limiting factor dyan, it will not, the yield of the plant will not be good. So, it's affected or limited. Yun ang ibig sabihin nito ng Liebig's law of the minimum. Okay. Miss Shirley's law of diminishing return, parehas din sa Liebig's law na of course, for every the same quantity of limit added successively until a limit is reached. Okay. Ito is magdi-decrease yung potential yield ng tanim if the quantity of that limiting factor element or that element is still limiting. Okay? For example, yung sabihin natin nga yung potassium. Pag limited yon, tapos ginamit ng konting potassium, tapos limiting na pa rin, hindi na, it will not reach its potential yield because of that limiting factor na potassium, so which is deficient in the soil. So all you have to do is to add first so that it will not be limiting the yield. Okay, yan. Now, the relation between the soil nutrient supply and plant growth. Example of diminishing yield. Okay. All right. Now, one bag of fertilizer will produce 10 kabans per hectare of rice, for example. And then 2 bags will produce 25. This will tell you that as you increase the amount of nutrient, it will be only at a certain point. It doesn't mean that kung marami yung fertilizer na ibinigay mo, it will also produce you the highest yield. Tignan ninyo kung 6, 7, 8, 9 na, magde-decline na. Kasi yun ang requirement ng tanim, na it only requires 5 bags for you to produce the potential yield of 90. Pag sinobrahan mo yan ng isang bag pa, magdi-decline na yung yield kasi wala na. Gastos lang ito. So, yan ang the relationship between the soil, nutrient supply, and plant growth. As you increase the amount of nutrient, it will increase the yield. But to a certain point, if we graph this, until 5, yun ang peak. Siguro 6, medyo pipik pa rin, it starts to decline na yung yield mo pag ginamitan mo pa. Kasi useless din ang mga nutrients na ito na ina-apply mo pag ganyan pala yung requirement. So it is only up to the requirement of the crop that will produce the potential yield of the crop. So yun ang end of the topic. Okay. Next module na.